Chapter 5 Water. When you think of water, what images come to your mind? You think of rivers, the waterfalls, the pitter patter of raindrops, water in your taps, etc. Children love to float paper boats in rain puddles. By noon, the puddles vanish. Where does this all water go? So, the question is, where does this water go? The sun's heat causes evaporation of water vapor. When the water vapor cools down, it condenses and forms clouds. And where it cools down? Above, high in the atmosphere, in the sky, from where it may fall on the land or sea in the form of rain, snow, or sleet. So I'm repeating this paragraph once again. The second paragraph. The sun's heat causes evaporation of water vapor. When the water vapor cools down, it condenses and forms clouds, from where it may fall on the land or sea in the form of rain, snow, or sleet. So, the process by which water continually changes its form and circulates between ocean's atmosphere and land is known as the water cycle. So, from here, the sun's heat till here. This is the answer of the water cycle. And let's revise the definition again. The process by which water continually changes its form and circulates between oceans, atmosphere, and land is known as the water cycle. And children, this is the diagram of water cycle. So you have to prepare this diagram along with the definition. Now let's come to a paragraph here. Our earth is like a terrarium. Now before we proceed the paragraph, let's read what is a terrarium here on the left hand side. Glossary. Terrarium. It is an artificial enclosure for keeping small house plants. Now coming back to my paragraph, our earth is like a terrarium. This line is very important. This may come as a filling the blank, like our earth is like a dash. So you have to fill the terrarium. The same water that existed centuries ago still exists today. The water used to irrigate a field in Haryana may have flowed down the Amazon River 100 years ago. The major sources of fresh water are the rivers, ponds, springs, and glaciers. So these four sources are the sources of fresh water. So you will find fresh waters in rivers, ponds, springs, and glaciers. The ocean bodies and seas contain salty water. So the ocean bodies and seas contain salty water. The water of the ocean is salty or saline as it contains large amount of dissolved salts. Most of the salt is sodium chloride or the common table salt that you eat. Now come back to the first page and let's read this green box on the left. Activity. How you can make your own terrarium at home. Fill 1/4 of a big jar with soil and press it well. Put a thin layer of humus on top of it. Plant the largest plants first and then arrange the smaller ones around them. Spray the arrangement with water and close the jar. The water that evaporates from the leaves and soil condenses and forms back in the form of drops of water. So here only you will be able to see the process of life cycle inside the jar only. Okay? So you can try this at home. Now come to the third page. Distribution of water bodies. Now we all know that 3/4 of the earth's surface is covered by water. If there is more water than land on this earth, why do so many countries face water scarcity? Now the answer to this question is because all the water is not fit for drinking. Only hardly some percent of water is fit for drinking. Okay. So here see you can see this. 97.3% water is saline water, salty water, and this water is not fit for drinking. Rest of the percentage, only this much water is fit for drinking. Okay, so this is hardly 2 point some percent. You can calculate and let me know in the comments. Just minus 97.3 from 100 and you will get to know the answer. Now let's come back to our paragraph. Is all the water on earth available to us? The following table gives the distribution of water in percentage. Now you have to learn this table well. This is also very important. Oceans contain 97.3% of water and that is saline water. Now fresh water. Now sources of fresh water, ice caps, groundwater, freshwater lakes, inland seas and salt lakes, atmosphere and rivers. and these are the percentages, and all this constitute to 100%. Now water distribution can be demonstrated by a simple activity like this. See activity box. Take 2 liters of water. Let it represent the total water on the surface of the earth. Now measure out 12 spoons of water from this vessel into another bowl. The water that is left behind in the vessel represents the salty water found in oceans and seas. This water is obviously not fit for consuming. It is saline. It contains salts. That only the 12 spoons of water that was taken out in a bowl is the total amount of fresh water on the earth. So this figure shows on the right, shows the distribution of this fresh water. See here, 9 spoons ice caps, 2 spoons groundwater, then half a spoon fresh water lake, then 1 drop, 1 river, right? So this percentage you can see here in this table. Here you will understand, okay, why they have kept 9 spoons as ice caps and 2 spoons as groundwater. Now let us revise these two definitions as well here. Do you know box? On the left hand side, the blue box. Salinity. Salinity is the amount of salt in grams present in 1000 gram of water. The average salinity of the ocean is 35 parts per 1000. So let's repeat. Salinity is the amount of salt in grams present in 1000 grams of water. The average salinity of the oceans is 35 parts per 1000. Water is absolutely essential for survival. Water alone can quench our thirst when we are thirsty. Now, don't you think we are wasting a precious resource when we use water carelessly? Yes, we are. Because if there will be no water in the future, how will we be able to survive? Just think about it, children. See, here are some newses. News you can see these posters, right? So here they are showing you that water, there is so much of water scarcity in our country, and if we will not save water now, we will face problems in the future. Okay, now ocean circulation, next page. There is something magical about walking bare feet on the shore. The wet sand on the beach, the cool breeze, the seabirds, the smell of the salt in the air, and music of the waves. Everything is so fascinating. Unlike the calm waters of ponds and lakes, ocean water keeps moving continuously. It is never still. The movements that occur in oceans can be broadly classified as waves, tides, and currents. Now let's read this do you know box on the right hand side. March 22 is celebrated as World Water Day, when the need to conserve water is reinforced in different ways. Now let's study about waves. When you are playing throw ball on the beach and ball falls into the water, what happens? It is fun to watch how the ball gets washed back to the shore by the waves. Now the definition of waves. Please learn it. When the water on the surface of ocean rises and falls alternately, they are called waves. Let's repeat the definition. When the water, see here, still here. When the water on the surface of the ocean rises and falls alternately, they are called waves. Now, during a storm, the winds blowing at very high speed form huge waves. These may cause tremendous destruction. An earthquake, a volcanic eruption, or underwater landslides can shift large amounts of ocean water. So, what all can shift large amount of ocean water? An earthquake, a volcanic eruption, and underwater landslides. So, as a result, a huge tidal wave called tsunami that may be as high as 15 meters is formed. The largest tsunami ever measured was 150-meter high. These waves travel at a speed of more than 700 kilometers per hour. This is a very, very, very high rate. Okay. The tsunami of 2004 caused widespread damage in the coastal areas of India. The Indira Point in the Andaman and Nicobar Islands got submerged after the tsunami. Now let's read these Two boxes. Do you know boxes left? Blue color boxes on the left. Waves are formed when winds scrape across the ocean surface. The stronger the wind blows, the bigger the wave becomes. Now you can add these two lines also in the definition of waves. So what we have studied here, the definition: when the water on the surface of the ocean rises and falls alternately, they are called waves. And then you can add this paragraph. Waves are formed, this paragraph, waves are formed when winds scrape across the ocean surface. The stronger the wind blows, the bigger the wave becomes. The next blocks. Do you know? Tsunami is a Japanese word that means harbor waves, as the harbors get destroyed whenever there is a tsunami. Now let's read this box. Tsunami, the Earth's pandemonium. Tsunami or the harbor wave struck havoc in the Indian Ocean on the 26th December 2004. The wave was the result of the earthquake that had its epicenter close to the western boundary of Sumatra. The magnitude of the earthquake was 9.0 on the Richter scale. As the Indian plate went under the Burma plate, there was a sudden movement of the seafloor, causing the earthquake. The ocean floor was displaced by about 10 to 20 meters and tilted in a downwardly direction. Because of that, a huge mass of ocean water flowed to fill in the gap that was being created by the displacement. This marked the withdrawal of the water mass from the coastlines of the land masses in the South and Southeast Asia. After thrusting of the Indian plate below the Burma plate, the water mass rushed back toward the coastline. Tsunami traveled at about a speed of 800 km per hour, comparable to the speed of commercial aircraft, and completely washed away some of the islands in the Indian Ocean. The, in, the Indira Point in the Andaman and Nicobar Islands, that marked the southernmost point of India, got completely submerged. As the wave moved from earthquake epicenter from Sumatra towards the Andaman Islands and Sri Lanka, the wavelength decreased with decreasing depth of water. The travel speed also declined from 700 to 900 km per hour to less than 70 km per hour. Tsunami waves traveled up to a depth of 3 km from the coast, killing more than 10,000 people and affected more than lakhs of houses. In India, the worst affected were the coastal areas of Andhra Pradesh, Tamil Nadu, Kerala, Puducherry, and the Andaman and Nicobar Islands. While the earthquake cannot be predicted in advance, it is possible to give a 3-hour notice of a potential tsunami. Such early warning systems are in place across the Pacific Ocean, but not in the Indian Ocean, and this happened in the Indian Ocean because there was no pre-forecast of this. Okay, so tsunamis are rare in the Indian Ocean as the seismic activity is less as compared to the Pacific. The tsunami that ravaged the South and Southeast Asian coast in December 2004 is the most devastating tsunami in the last several hundred years. The large damage caused to life and property was primarily a result of lack of monitoring, the early warning systems, and knowledge about the coast dwellers of Indian Ocean. The first indication that tsunami is approaching is the rapid withdrawal of water from the coastal region, followed by a destructive wave. When this happened on the coast, instead of people going to high ground, they started assembling at the coast to view the miracle. As a consequence, there was a large casualty of curious onlookers when the gigantic wave tsunami struck. If these people would have went away from the coast, they will be able to save their lives. But instead of going away from the coast, they went towards it to view the miracle, and that led to huge destruction and large number of casualties at that time. So many people were killed. Tides. The rhythmic rise and fall of ocean water twice in a day is called a tide. So this is the definition of tide. The rhythmic rise and fall of ocean water twice in a day is called a tide. But you can add along with this also the next line. It is a high tide when water covers much of the shore by rising to its highest level. It is low tide when water falls to its lowest level and recedes from the shore. So you can either add this whole paragraph for the, if you get a question and write the definition of tides, or if you will get a question, tell us how the tides are formed. So then you have to write again this whole paragraph. Okay. Now next page. The strong gravitational pull exerted by the sun and the moon on the earth's surface causes the tides. Okay, so how the tides are caused? The strong gravitational pull exerted by the sun and the moon on the earth's surface causes the tides. The water of the earth closer to the moon gets pulled under the influence of the moon's gravitational force and causes high tides. Right? So how the high tide is caused? The water of the earth closer to the moon gets pulled under the influence of the moon's gravitational force and causes high tide. Now during the full moon and the new moon days, the sun, the moon and the earth are in the same line and the tides are the highest. You can understand by the diagram here on the left hand side. This diagram, during the full moon and the new moon days, the moon and the earth, they are in the same line and the tides are highest. These tides are called spring tides. But when the moon is in its first and the last quarter, the ocean waters get drawn in diagonally opposite directions by the gravitational pull of the sun and the earth, resulting in low tides. So these are called neap tides. So this is the definition and this is the diagram of neap tide, and here this definition here. When the moon is in its first and the last quarter, the ocean waters get drawn in diagonally opposite directions by the gravitational pull of sun and earth, resulting in low tides. So this is the definition of neap tides. Now high tides help in navigation. Now here you can get a question that what is the importance of high tides or how high tides are useful. So the answer will be high tides here. It will start from here. High tides help in navigation. They raise the water level close to the shores. This helps the ships to arrive at the harbour more easily. Then number 3, the high tides also help in fishing. Many more fish come closer to the shore during the high tide. This enables fishermen to get a plentiful catch. Then number 4, the rise and fall of water due to tides is being used to generate electricity in some places. So this would be number 1. First point. Then this would be number 2 point. Then here you will get number 3 point. The high tides also help in fishing. Then number 4 point here. The rise and fall of water due to tides is being used to generate electricity in some places. Now ocean currents. Ocean currents are streams of water flowing constantly on the ocean surface in definite directions. So this is the definition of ocean currents. Ocean currents are streams of water flowing constantly on the ocean surface in definite directions. The ocean currents will be warm or cold. Generally, the warm ocean currents originate near the equator and move towards the poles. The cold currents carry water from the polar or higher latitudes to tropical or lower latitudes, because in the polar region it's very cold there. Okay, ice cold there in the polar region. So the cold currents carry water from polar or higher latitudes to tropical or lower latitudes. That is why they are called cold currents, because they are carrying water from the polar region. Then we are here. The Labrador ocean current is cold current. So this is the example of the cold current, the Labrador ocean current, and the example of the warm current is Gulf Stream. So you have to learn both these examples. They can ask you in the school, they can ask you, give an example of cold current or give an example of a warm current, or Labrador ocean current is which type of current. So then you have to write it's cold current. Okay. Then come here. The ocean current influences the temperature conditions of the area. Warm currents bring about warm temperature over land surface. The areas where the warm and cold currents meet provide the best fishing grounds of the world. Seas around Japan and the eastern coast of North America are such examples. The areas where a warm and cold current meet also experience foggy weather, making it difficult for navigation. Okay, so here we come to the end of this chapter. I will upload the exercise in the next video. Thank you.